Hello, everybody, and welcome to Chapter 2. We're starting on page 63 in your textbook. And this is the Getting Ready page. So it has a few things that you might encounter during the lessons and you might need to know, or a good review. And then we're only doing lesson 2.1 so far, which is after this. I'm going to try to make that a little bit bigger. There we go. Identifying angle pairs. So this chapter 2 is on angles. And we had a little lesson on angles in chapter 1. So a linear pair, my pen isn't working again. Identify all pairs of each type of angle in the diagram right here. So a linear pair is angles that form a straight line. And a straight line is always 180 degrees. So you can have two angles that will add up to 180 degrees. That's called a linear pair. So I'm looking here, I see angle. This is your angle symbol, 5 and angle 2 form a linear pair, and also angle 1 and angle 5. These two form a straight line linear pair. Complementary angles, sum is 90 degrees. So they form a right angle. This is the symbol for right angle. So this is these two, 3 and 4. And vertical angles are the ones when two lines cross, they're across from each other. So we have 1 and 2. These two are vertical, that's all I see. 3 and 4, by the way, are not vertical angles. Supplementary angle, the sum is 180, and they don't have to be attached to each other. Like a linear pair has to have a common vertex. This is called a common vertex right here. Supplementary, they don't have to have a common vertex. They can be two separate angles, but I don't see anything. So I'm going to use the same again, angle 5 and 2. Those are also supplementary. And angle 1 and 5 are supplementary. Okay, then review on justifying statements. The property that was in lesson 1.7, if 3x is 6 and x is 2 is the division property of equality. If angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 must be congruent to angle 3. So you can skip the middle and set the first and the last equal to each other. That's called transitive property, and it's congruence because the symbol. And then we have review on solving equations. So I'm going to pick one and you do the other two. I'll say I'll do number 9. 2x plus 5 grouped together plus 3x minus 10 grouped together, 70. So you can combine your like terms, the x's and the numbers. 2x plus 3x is 5x. 5 minus 10 is negative 5. Add 5 to both sides. 5x is equal to 75. Division property, divide both sides by 5. 75 divided by 5 is 15, I believe. Okay, so you do number 7 and number 8. And then we have some vocabulary words. The core of an apple is in the interior of the apple. The peel is on the exterior. Interior, exterior are words you're going to see today. Applied to geometric figure. Interior is inside the figure, and exterior, something outside of a figure. A ship sailing from the United States to Europe makes a transatlantic voyage. What does the prefix trans mean in this situation? Transatlantic, it crosses the ocean. So trans means crossing, yeah? A transversal is a special type of line in geometry. What might a transversal do? Crosses something. A line that crosses something. Okay, and then we'll start with our lesson. So make sure you do 7 and 8 and try it. You might show your work on some other paper because there's not enough room unless you can squeeze it in here. All right, then we're going to the lesson. It's on page 65 and it's on lines and angles 2.1. So underline the title. And then objective to identify relationships between figures in space. Space is 3-dimensional. And to identify angles formed by 2 lines and a transversal. Okay, and here on this space, I want to put some vocabulary words you need. So a plane is a 2-dimensional, it's a flat, like a sheet of paper. So you can draw like a paper, but in most textbooks, it's tilted sideways like that. So a sheet of paper is a plane. The whiteboard at school is a plane. It's a flat surface, 2-dimensional surface. Oh, wait, 2-dimensional surface. And it depending on how it's tilted, it has a fixed direction or fixed tilt, because each time you tilt it a little differently, it's a different plane. Fixed direction or tilt. So every plane has its own tilt. Like think of the whiteboard, if I move it toward me a little, like I change the angle, it's a different plane. So there's infinite many planes because you can take a flat surface and tilt it in every which way. Coplanar, the word coplanar is 2 things that are in the same plane. Items or whatever we're talking about, lines, points, items that are located in the same plane, or on the same plane, I should say. And then the word non-coplanar is the opposite. Items that are not located on the same plane. I'm just going to put little tick marks that tells me I have to say the same thing over, right? I'm just inserting the word not, non-coplanar. A segment is a line that has a beginning and an end. So a beginning point and an end point. So you can actually measure this distance, and the beginning point and end point are denoted with capital letters. Might be like AB, okay? It doesn't have to be AB, but I'm picking those. The main thing is this is a segment, and then you have a ray. A ray has one beginning point, but no point. So it starts somewhere, but it keeps going in one direction. And then you'll, of course, have lines. And lines go on in both directions forever, have no end in both directions, okay? And I think that's pretty much it. Again, the angle symbol. So we don't want to confuse that with less than, or it's flat on the bottom. That means angle. Okay. And this, well, one more symbol that you'll see, this means parallel. Okay. And essential understanding, this right here is going to explain a lot. So I'm gonna go over that. Why is that all dark? That's weird. All right, not all lines and not all planes intersect. So when you intersect, that means you coincide. You like think of an intersection, you kind of, that crosses, right? So I'm gonna use the word crosses. Intersect. Okay, this is called parallel. It's dark. Parallel lines. Definition, parallel and skew. Parallel versus skew. Parallel lines are coplanar in the same plane. Lines that do not intersect, like railroad ties. And the symbol, 2 double bars, means it's parallel to. So here's our symbol. Line, this is a line. Notice you have arrows at both ends. Line AE is parallel to BF. So I'm going to look here. AE is this line. I'm going to color it. You don't have to, because I'm going to erase it. AE is parallel to BF. Notice they're parallel. They'll not intersect. Okay. I just wanted to, I don't need to trace those for you. I think you get it. Skew lines are non-coplanar, so they're not on the same sheet of paper. They are not parallel and they do not intersect. Those are the hardest ones. So you have to kind of look for those. AB and CG. AB, this line, and CG, and this line are skew. They're not parallel, they're not on the same sheet of paper, and they will never intersect. So that's kind of the deal with skew lines. And then parallel planes are planes that do not intersect, like the top and bottom of that shape here. Parallel planes do not intersect, like this top and this bottom. Those two are parallel. Okay, and a plane is denoted by a minimum of 3 points on the plane. But these people here do 4. So, but you only really need 3 in case you ever wonder. Plane ABCD, A, B, C, D. That's the top, parallel to plane EFG, H. E, F, G, H. That's the bottom. Okay. And this is your symbols, that those arrows. A line and a plane that do not intersect are parallel. Segments and rays can also be parallel or skew. And then I'm moving on to the next page. Make sure you understand this, the key concepts. And then we're going to work out to answer some questions. And I'm hoping this is easy for you. This lesson should not be hard. If it is, then it's hard for you to see this is a 3-dimensional figure. It has length, height and width. Notice length, height, and width. It goes this way. So 3 dimensions. Which segments are parallel to AD? So this right here, that's a segment. Notice it has, okay, it has only a line above it. That means it's a segment. So that's simple. My pen is not working. Which segments are parallel to that tree? EH. And so EH is this one. And then BC, which is this one in the back. And FG, which is this one. All right. Explain why FE and CD are not skew. So first I want you to look for the 2 segments, FE and CD, and think about that yourself. FE and CD are not skew because they're parallel. FE and CD, these 2 are parallel. And you can use this symbol for parallel. And is another pair of, what is another pair of parallel planes? I'm going to skip that. What is another? Well, we have the top and the bottom. Well, they don't even ask for one in the beginning. What are 2 segments? Oh, I switched this. What is another pair of parallel planes? So you have, we can do the, how about ABFE plane, ABFE parallel to plane CGHD. CGHD. I'm going to go move on because I think you understand that. I'm hoping. To the bottom, this diagram right here, and 2 lines that are skewed to EJ. So the skew ones are usually the ones that are a little harder. So first I identify my line that they're giving me. And skew would be this one, DG. And another one skew would be HB, skew to this one. Okay, I'm moving on to the next page up on top. This is important. This is page 67. This is where we're going to learn about the angle pairs, transversals. Okay, so let's read that. When a line intersects 2 or more lines, the angles formed at the intersection points create special angle pairs. So your job is to know what those angle pairs are called, okay? And you notice this right here is the line that crosses. So that's called a transversal, and it's lowercase t in our picture. And this is line L, and this is line M. So these 2 lines and our transversal crosses it. There's 8 angles that are created. 8 angles. So these all have names, pairs. They go in pairs. Yeah. Okay, so we need to know 4 angle pair names, okay? Notice that, and then we have exterior on the outside and interior on the inside. You should notice exterior is on the outside of our diagram, interior is in the middle, inside. Notice that angles 3, 4, 5, and 6 lie between, or the interior. 3, 4, 5, and 6 are interior angles. And angles 1, 2, 7, and 8, 1, 2, 7, and 8 lie on the outside, and those are called exterior angles. Okay, on the outside of line L and M. Okay, pairs of 8 angles have special names as suggested by their position. So you can kind of remember these names. Here they are. This one didn't come out, but so let's look. Angle pairs, so you're going to definitely refer to this because your homework, you got to answer the what's the angle pair name. So you refer to this a lot. On homework. Okay, alternate interior angles are 4 and 6. And the word alternate are on the opposite side of transversal. That's the word alternate. And then 5 and 6 are also alternate, and those are interior angles. So alternate interior. No, not 5 and 6. 5 and 3 are also alternate. On the, this is your transversal. They're on opposite side of transversal, on the inside, on the interior between the two lines. Same side interior, well, they're on the same side of transversal on the inside. So 4 and 5, these two are on the same side of the transversal on the inside. Same with 3 and 6. They're on the same side of the transversal, which I made blue, on the inside or the interior between the two lines, same side interior. This is called corresponding. And corresponding angles, one angle is inside and one angle is outside always. So 1 and 5, notice one is outside, one is inside, and they're on the same side of transversal. And then 4 and 8. One is inside, one is outside, same side of transversal, and so forth. 2 and 6, 2 and 6, 3 and 7, 3 and 7. Those are all corresponding. So there's 4 sets. Yeah, so that's one of the homework questions. How many of each? 2, 2, 4, and 2. And then we have alternate exterior, outside. Exterior alternate again means opposite of transversal. And now on the outside, 1 and 7, exterior, all on the opposite, alternate, and 2 and 8, 2 and 8. Opposite of the transversal and on the outside. So those are the angle pairs you need to know. So those 4 words or whatever they are, definitions, you definitely want to go back to. And now we're going to look for those here. What are 3 pairs in our figure here? We're on page 68. In our figure, what are 3 pairs of corresponding angles? So I'm looking for my transversal. They're not always called T, by the way. This one is called R. Notice? It's just that you have to see which one crosses. It always crosses 2 lines. So you can kind of identify it. So corresponding, I have written down angle 1 and 3. 1 and 3. And then I have angle 8 and 6. 8 and 6. And angle 5 and 7. 5, and 7. And now this one is harder because they give you a very convoluted picture, meaning there's more stuff going on than we want to know. So I'm going to use these two lines for right now. A and B, lines A and B, and make this my transversal, and then look for same side interior angles. So which one would that be? So it would be same side interior. It would be this one and this one, these two. Okay, so angle 7 and the sum of angle 3 and 4. Because you have to add these two up. They have to be from here to here and from here to here. Those are called same side interior. And what lines create that? Lines A, B, and D is transversal. So you have to kind of pick out what you need to look at and ignore the rest because there's a lot of stuff going on. So now we're going to look for alternate exterior angles. So I'm going to erase this because I have to maybe use some other lines. Alternate exterior. So if I pick these two, then I can use that as my transversal, but they don't have. So how about if I use A and B again? And still do that, that would be angle 8 and angle 6. Yep, these two. So you have A and B again, and here's my transversal, and these are alternate exterior. And it's again lines A, B, D is transversal. Do I have one more? Nope, that's it. So next page up on top, let's look for this picture right here, aviation. The photo shows an overhead view of airport runways. So here's your planes. They line up for takeoff, and that's the runway, and there's another one, and this is a transversal. Okay. Are angle 1 and 2 alternate interior, same side interior, corresponding alternate exterior. So when you look at the diagram, you identify angle 1 and angle 2 and decide that those are called corresponding because one is on the outside and one is on the inside of our two lines. So those are called corresponding. Okay. So homework, I have a lot of work for you, but it's short questions. There's no real math involved. So please don't despair and go, oh my gosh, because usually I give you very few homework questions if they involve a lot of computation. But in this lesson, all you have to do is look at the pictures and come up with parallel segments. EF and HG are parallel. Parallel planes, alternate interior. You got to identify the angles. Which ones? Don't forget the angle symbol, this one. Corresponding, alternate exterior. So your diagram is here. This is your transversal. So this is the one that decides, is it on the inside, outside, opposite side, same side? So that's this page. And then on this page, we're now on page 70. You're going to do number 15. Also number 16, error. There's an error, maybe. I don't know. And then down here, all of those. How many pairs of each type of angles? I talked about that. You can just look at that previous page and count them. Besides vertical angles, that's not there. You have to kind of look at the picture and count them. And then this one, go-karts on different tracks. Is it skew, parallel, or neither the two tracks that they're describing? Okay, And then on this page, these are really short, guys. These are true, false questions. Describe the statement as true or false. So that's it. If false, explain. So if it's false, say no because. All right, so that's all of these. So you're looking at this diagram here. You're also doing number 28. This is about a rug on the floor and the wall. Are they parallel or not? That's it. Okay. And please don't be discouraged. They're really short answers. You don't have to do any computation. Really, I haven't used any math, really. So I'll see you soon.